All right. Okay. So we'll take a look at stuff. I posted your first homework assignment. Okay. So, okay. Let me see. All sorts of technical issues today. So it's available under week 1, and there's I guess an activity called homework 1, and basically you'll follow the instructions there. There's a few things to code. Is this gonna work? Okay. All right. So you'll open up homework 1. And then you'll download the instructions. This is your output file that you will modify with your answers and put stuff in. You'll also write a script file, okay? So the instructions are here in that. So you'll submit 3 files. One will be an R file with your scripts, and then you'll also fill out. There's a few questions for you to answer in the RMD file. So you'll open up your RMD file. You'll kind of source your scripts, answer your questions in there, and then you'll render it and generate it as a PDF, and you'll submit those files. Okay. I'm assuming everybody is familiar with working with RStudio and the R Markdown files, and know how to edit Markdown and output PDFs and HTML files. Is that correct? Okay, this is, okay. Well, if you have issues, come see me during office hours and we'll figure this out, okay? All right, and then there's just a few scripts for you to write. This feels really loud. Let me see. Okay, I don't know if that's any better. So follow this, and again, the point of the homework is for it to be an exercise and not that the task gets done, right? So I have you, one of the things you write up will be prime factorization, right? You take a number and you break it down into its prime factors. And there's a lot of scripts already out there on the internet, okay? If you type in prime factorization code in R into Google, you're gonna get some hits, okay? Don't run that search, and don't look, and don't be tempted, because once you look at it, it's going to taint your ideas for how to approach the problem, okay? What's best is you say, well, how do I do a prime factorization myself by hand, right? So you have like the number, let's say you have the number 12, right? So you start by saying, okay, well, what prime numbers can I divide into 12? You put in 2, you do 12 divided by 2, and you get 6, and you go, okay, well, how do I factor 6 into prime numbers? And you go, okay, that factors into 2 and 3, and so your prime factorization is 2, 2, 3, right, for 12. And just kind of try out a few numbers, some bigger numbers, and write down the logic that your brain's going through. And I think it's simple enough that everybody should be able to do it, okay, with a little bit of effort. And it's also complex enough that no 2 people are going to have the exact same identical code. Of course, everyone's going to probably do almost identical approaches, because there's really only a few approaches as far as prime factorization goes. But if I just tell you, write a sentence about, what you did this morning, okay, probably no 2 people are going to have the exact same sentences, okay? In the same way, no 2 people should have the exact same code, even though your approaches might be identical, okay? And so, so anyway, try it out. The goal is for you to just get some exercise and practice writing. I don't actually care if I'm not going to use your code for anything here. Okay. All right. So let's we'll start going into covering our code and our programming stuff, and a lot of this should be review from Stats 20, but we're going to kind of just go over everything again. And so we'll start with just your basic data structures, okay? And so, kind of your most basic and most important family of objects in R are the vectors, these atomic vectors and generic vectors, okay? We might call generic vectors lists. But here's a question. What's the primary difference between an atomic vector and a list? You guys should know this, yeah.
Atomic vectors all have the same data type?
Atomic vectors have all the same data type, okay? Lists can have a mix of data types, okay? And as far as data types go, we've got different data types. We've got the logical, the double, integer, character, complex, and raw, okay? We primarily deal with only the first four, okay? Complex being stuff for like your complex and imaginary numbers, and then raw is kind of how things are encoded in memory, okay? There's also mode and storage mode. Mode will just treat double and integer as numeric, but I like to make a distinction between them. Double being floating point double precision. This is kind of your, you store a number, a real number, or you represent a real number using 8 bytes, okay, 64 bits of data to represent a real valued number. And we'll talk about floating point arithmetic later on in the course, but you know, there's infinitely many numbers that are out there, right? And you can there's only a finite number of numbers you can represent with 64 bits. You can represent a lot. 2 to the 64 is a lot of numbers that you can represent, but there's that's still a finite number of values that can be represented. So there's some implications there, okay? So we'll talk about that, and it's called double because as far as computer programming goes, there was single point floating, single precision floating point numbers, which uses 4 bytes or 32 bits, and then there's double precision floating point, which uses 8 bytes or 64 bits. Like if you were programming in a language like C, it makes a distinction, and you can have single precision and double precision. Pretty much today, everybody's got tons of memory. Okay, you've got like, what, 4 gigabytes, 8 gigabytes on your laptop. So whether you're using 4 bytes or 8 bytes to store your numbers, probably not going to make a difference. Okay, and so R really only supports double precision floating point numbers. Okay, so we've got these are your 4 primary types: logical, double, integer, character. Logical is also called Boolean. All right, so integers in R are stored using I forget how many bits, but a certain number of bits, and that is what is created when you use the colon operator, or if you want to specify a number. By default, if you type in the number 3, it's going to create a type double number 3, and if you want to say, no, this 3 is an integer, you type in an L after it, okay? So if you type in create a vector 1, 2, 3, R is going to say this is type double, okay? Anything with a decimal, like pi, 3.1, 7.2, anything with a decimal is going to be type double as well. If you want to make it an integer, you type in an L, capital L after the number, and that will specify that it's an integer. If you use the colon operator, okay, 1, 2, 3 and 1, 2, 3 using the colon operator look the same, but internally they're different. 1:3 is an integer type, okay? I think this was probably covered in Stats 20, is that right? Okay, so this is review for us, right? Okay, and then we've discussed the distinction between atomic vectors and lists, and the primary difference is that atomic vectors all have to have the same data type, and so we'll call these homogeneous vectors, okay? And if it's one-dimensional, then it's an atomic vector, right? As soon as you take an atomic vector and you make it 2-dimensional, it becomes a matrix, okay? So matrices also have to be homogeneous in that everything has to be of the same data type. So you can have a whole bunch of integers in there, but as soon as you put in one decimal value in there, a floating point number in there, then the entire matrix becomes a type double matrix, okay? And then if you throw a character into a matrix, then it will change the entire matrix into type character, right? So it coerces everything so that everything in the matrix or atomic vector has to be of the same type. Whereas when you have a data frame that's going to be your 2-dimensional structure or a list, which is data frames are just stored as lists. That allows you to have mixed data types. You can have one part of the list be integers, another part of the list be logical values, and another part of the list be character values and things like that. Okay, and so so you can have that in a list, and then a data frame. Similarly, one column can be numbers, and another column can be characters, and that's so you can contain attributes about different observations with a data frame. Okay. If you want more than 2 dimensions, you can create an array. I would say an array is used less frequently as far as kind of basic things, but I don't know. If you go into Python, they have arrays, and you have these high-dimensional arrays. They call them tensors, and they often use them for neural networks and stuff. And so the neural network package TensorFlow is kind of the idea is you have these high-dimensional arrays and stuff. And R could do the same, but not as common, right? Okay. Pretty much all of your objects, your vectors, whether they are atomic or generic vectors in R, can have attributes, okay? And an attribute is basically, attributes are stored as a list that get attached to the object, okay? So you have like an atomic vector, and then you attach this attribute list, and you've got different attributes there, right? And you can technically have any attribute you want. Probably the most important ones will be things like your names, your dimensions, row names if you're talking about a data frame, and the class, okay? You guys covered attributes in Stats 20 as well? Yeah, okay, so how do we get the attributes? Well, there's the attributes function, right? Attributes, and then there's the attr function to set attributes, okay? I guess we'll answer these questions as well, right? How is a matrix different from a data frame? We'll answer that. What's a factor, and how's a factor stored internally in R? Okay, so let's talk about these attributes, right? So here's a data frame, trees. Okay, so this is just the first 6 rows of trees. We do head trees, and we've got the column girth, the column height, the column volume, okay? All right, so if I ask, what are the attributes of trees? You guys remember the attributes of a data frame? What are we gonna get? What's that?
Dimensions.
Dimensions. Does a data frame have the dimensions attribute?
I would have to imagine it does.
Yeah. So we think, we're like, okay, a data. So this is one of those tricky things, right? These are like, it makes sense that a data frame should have dimension attributes, but it actually does not. It actually does not have dimension attributes. Okay. So when you type in dim on a data frame, it will, like if here, let me just clear everything out here. Whoops. Okay, so here is trees. This is what it looks like. I gotta make this bigger for you guys. $150, is that how big I want to make things? Okay, oh, geez. All right, okay, so if I type in dim trees, why is that not working? Okay, it spits back and it says it's 31 by 3, okay? But there's actually no attributes for dimension in trees, okay? So for a data frame, it actually doesn't have a dimensions attribute. Okay, what does it have instead? There's three things. Like if you type in attributes of trees, it's gonna spit back 3 things. One will be names, okay? And basically the column names, okay? So we're gonna get back the column names. All right, column names has a length of 3, and that's how the dimensions function gets that, okay? What else does it have? it's got a row names attribute, and row names. The row names are the numbers 1 through 31, stored as I think as characters, and then the last is it's got a class attribute. Okay, class is data frame. Okay, so this is what we got. Actually, it's not characters here. So so the names. So these are it. The names, the class, and the row names. Okay, and so when you type in dim of trees, what it does is it says, oh, row names has length 31, names has length 3, and so it's going to come back and say 31 by 3. Okay, and then it's a data frame class, which informs R how it should print out, right? So when R says it's a class data frame and I say what is trees, it prints it out like this. Internally, if I say type of trees, what will this return? Internally, how is this stored in R? A data frame. It's stored as a list, okay? And I can say print.default trees, and it will print the way a list gets printed out, okay? And it comes back with attribute class data frame here, okay? I know, it feels like they're small details, but they're also important distinctions, okay? Students often ask, like, why do you test us on these weird things? Like, why does everything feel like a trap? We're not trying to trap you or trick you or anything, right? When I ask you, like, I think a perfectly valid question now that we've talked about it in class is to say, you know, does a data frame have a dimensions attribute? And you got to know that the answer is no, right? It's not that we're trying to trick you or trap you into these weird tiny details, but these things do make a difference when you are coding, and how you perceive and the knowledge that you have about these things make a difference in how you're going to write and approach your programming. So, yes.
So internally, are data frames lists holding lists?
Data frames are lists of actually vectors of the same length. Okay, so it's so data frame is a list with three vectors, and each vector is of length 31. Okay, and if I break any one of these things, right? So if I do trees $, volume, and if I type in 30, like if I give it like this, right? Okay. Oh, actually, well, it's smart. It says it's a data frame, so you can't do that. Okay. All right. Let me just do. All right. Okay. So first, I'm going to make a copy of trees, and then we'll do class of this is data frame, and I'm going to null this out. Okay, so if I do this, I'm going to get rid of the class of this object. Okay, so class now is just this thing, and now because it's just now it's just a list, I can throw in and say $volume. I'm going to throw in an object 10 here. Okay, the name 10 right here for here. So this one is now length 32. And if I try to turn this back into a data frame, then it says I can't do that. Okay, so a data frame is stored as a list of vectors, but all of the vectors have to be of the same length. Okay, and that makes sense because you need it to be a rectangle, which means all columns have to be of the same length. Okay, anyway. You can throw in the attributes, you can just throw in some arbitrary information. Like I wanted to just create an attribute called info. And because the attributes is stored as a list, you can just do that, okay? This is not typical. This is not standard practice, but it's possible, okay? All right, a matrix. Let's talk about a matrix. Okay, so a matrix is just an atomic vector, and then we give it a dimension attribute, okay? So here's the atomic vector 1 through 10, vector of integers, And if I say, what is its class? It's going to say class integer, okay? All right. And here, I just say, okay, set the attributes of this atomic vector, set the dimension attribute to be 2 by 5. And now when I asked what is M, it prints it out as a 2 by 5 matrix, okay? I didn't redefine M, I just changed the dimension attribute here, okay? And now it has the dimensions attribute. And now when you ask for the class, it's a matrix, all right? Here, let's go back. So M is 1 through 10, okay? What's type of M? Type of is integer, right? Okay, so now I'm gonna do attributes of M. We're gonna give it some dimensions here. Okay, so M looks like this. If I do type of M, what am I gonna get here? It's not class, but it's type of. The type of here is still integer, okay? So internally, it's still stored in R as an integer, okay? M looks like this. I can go back and I can change the dimensions of M to be 5 by 2, okay? And M now looks like this, okay? So, and if I wanted to, I could get rid of the dimensions attribute. I can null them out, and M returns back to an atomic vector, okay? So internally, R just has an atomic vector, and then if you apply dimensions to it, it just reshapes it to be a matrix. Notice that reshaping this is very different. This is not the transpose of this, right? Transpose is a completely different function. Transpose takes it and makes the rows columns and the columns rows. That's not what we're doing. We're reshaping all of the data. We're kind of reflowing it. Okay. When you do this, it flows vertically, right? So it goes down this column, 1, 2, 3, 4, 5, and the next column, 6, 7, 8, 9, 10. All right. Arrays are like matrices, higher dimensions. Okay, so we've got more than 2 dimensions. We've got 3 dimensions here. Okay, so this will be, you can kind of think of it as rows and columns, and then this will be, I guess, the number of sheets. And then if I had a 4th dimension, it'd be like the number of blocks. And then if I have a 5th dimension, I guess it'd be the number of hypercubes or something. I don't know. Okay, and it fills out. The way it fills out is it fills out in the order of these dimensions, right? So it fills down the rows. Okay, 1, 2, 3, 4, 5, 6. Okay, down the rows, then across the columns. Okay, so down the rows, and then once this sheet has filled up, it moves to the second sheet, and it fills this out 7, 8, 9, 10, 11, 12. Okay, and this is an array, and this represents now a 3-dimensional structure. Okay, and I guess you can think of it as like your 3D tic-tac-toe or something. I don't know. There's like memes about 3D chess, but I don't even think I don't think that's like a real game that exists. Is it? It is. How does the knight move in 3D chess?
I don't know.
Okay.
It's not. It's actually more simple than 2D chess, though.
More simple than 2D chess? Okay. Well. I guess anybody can play it then. All right. So you can create an array using an array, and you have to give it a dimension attribute, or you can just take the vector and apply a dimension array. All right. All right. Okay, so we've already talked a little bit about this. Data frames are stored internally as lists of equal length vectors with a class attribute data frame. Okay. And so here's just the first 4 rows. It's a data frame. It's stored, the type of, stored as a list. Okay. And then now we'll talk about factors, right? So factors are weird, but they show up all the time, and they're important, okay? So what does a factor do, right? So it takes usually the way a factor ends up getting created is when you do something like read.csv or something, R takes in and says, oh, we've got some character information, and it makes it a factor. The default setting is strings as factors is true. And if you don't like that, you should do strings as factors false. But here's a factor, right? So here maybe we've got the gender attribute, male, female, unspecified, or non-binary or something. And we've got this, right? So we do gender as a factor, okay? So we've got this. Gender is just a character vector. And if I say take that character vector and make it a factor, then we get this, gender as a factor, and we get this, right? Right away, one thing that cues us in that this is not a character vector is what? Aside from the levels, the fact that you see levels immediately tells you it's a factor. But what else is different about this in a character vector? There's no quote marks, right? So anytime you print out a character vector, you get quote marks around it, okay? And the fact that the quote marks are missing is an indication to you that this is a factor, okay? These are the details that you pick up and notice right away after having worked with R for a long time, right? It's kind of like the bankers can detect counterfeits right away because you just become accustomed to dealing with the real money all the time, so anything that seems different seems off. And anytime you see something without quote marks around it, you go, okay, well that's not a character vector, right? Okay, and then the levels is also a clear giveaway that now we're dealing with a factor. Okay, and we can ask, what are the levels? The levels themselves are a character vector. The character vector with the characters f, m, and x. And if you ask, how is the factor stored in R? It's stored as type integer, right? So if I take this gender factor and I say, convert it to a numeric thing, what am I going to get back? This m will turn into what number? Look at the levels. Okay, the m turns into a 2, the f's turn into 1s, and the x turns into a 3, okay? So by default, when you just give it a thing, a character vector, by default, R is going to alphabetize these and then assign the first thing in the alphabet 1 and the last thing the biggest number there, okay? So F comes before M in the alphabet, so F gets assigned 1 and M gets assigned 2. Now if you wanted to change that, you can also specify in the specification of the factor exactly the order of the levels that you want and how you go that, but by default, it goes alphabetical order. And because F shows up first, all of these F's get turned into 1s, and M is a 2, so that's what happens, right? So if I do as.integer for this, I get exactly what I said. I would get 2, 1, 1, and 3, okay? And then if you ask for the attributes, okay, the factor has 2 attributes, levels and a class, right? The levels is this character vector that translates from the integers into the characters that appear on the screen, and then class, you can't see it, but it's going to say factor, okay? All right, so what happens, though, is that factors will do things that are a little bit unexpected sometimes, right? So here I've got some numbers, 0, 1, 10, and 5, and I can take x, and make a factor out of it, right? So here I've got x as a factor, x factor here, and it says 0, 1, 10, 5. Now, this by itself, if you didn't see the levels, doesn't look all that different from like an integer or numeric vector, okay? But the fact that we have levels here clues us in and says, okay, this is a factor, right? And if we say, okay, well, what is the mean? What is the mean of these things? If you do mean of this factor, it tells you, it says arguments not numeric or logical, so it's going to return NA, right? And that's a good thing, okay? Because it doesn't make sense. Because when do we use factors? Yeah.
Usually it's categorical.
For categorical variables, right? Okay? And so categorical variables, even if the category is a number, those numbers do not have meaning. And it doesn't make sense to do things like take the mean, right? So can you guys think of a categorical variable that's a number? or that looks like a number.
Number of cylinders in a car.
Number of cylinders in a car. I would argue that's still a numeric variable because it actually quantifies how many cylinders are in a car, right? So you can say this car has 4 cylinders and this car has 6 cylinders and this car has 2 more cylinders than this car, right? Yeah. Age it would also be a numeric variable. You can say this person's 35 and this person's 28, this person's 7 years older. It makes sense, right? Okay, here, let me, I'll give you the answers I'm thinking of, okay? Something like area code, okay? If you take your phone number, you have an area code. Some of you have area code 310, some of you have area code, I don't know, 818, 562, okay? It does not make sense though, even though they're numbers. You cannot say this person's area code is 818, this person's area code is 310, this person has 508 more area code than this person. That doesn't make sense, right? As soon as it does not make sense to make a comparison and saying this is more than this, that's a clue that it's not categorical. Same things with zip code, right? So you've got zip code 90095 and 91 whatever zip code we are right here, okay? You cannot say, okay, here are 2 zip codes, I've taken the difference, and this person has 10,300 more zip code than this other person, okay? That kind of comparison doesn't make sense. And so zip codes, even though they look like numbers, are actually categorical variables. And so it would make sense to take a zip code and make it a factor, or area code and make it a factor, okay? And so when you say, well, what's the average area code? That's a nonsense question, right? So R comes back and says, well, you're giving me something that's not logical, okay? Or I'm sorry, not numeric. So it's missing, right? But you know, someone stubborn might say, I still want my average area code, okay? And so you might be tempted and say, well, okay, well, let's do as numeric, and then, and what do you get? You get 2.5, and you go, well, that doesn't make sense. The numbers were 0, 1, 10, 5. That adds up to 16. 16 divided by 4 is 4. Why am I getting 2.5? Well, what's happening is, as numeric, the factor is actually stored as 1, 2, 4, 3, right? These numbers, 0, 1, 5, 10, get recoded as 1, 2, 3, 4, and so the average of 1, 2, 3, 4 is 2.5, okay? So if you actually do want to like treat these as numbers and take the average, then you got to do something weird, right? Like turn the factor into characters. It uses the levels and turns that into that. And then you say as numeric, and that turns it into the numbers. And then you can take the mean and you'll get the number 4, okay? Moral of the story, factors are for categorical variables, okay? And you shouldn't be taking averages of categorical variables, okay? You can't say, this person has red hair, and this person has black hair, and this person has blonde hair, and what's the average hair color? Like, I guess you could take things and mix them, I don't know, right? It doesn't make sense, right? So you have to find a way to represent these things numerically, and now that we've got digital photos, you can represent colors as numerically and then take an average that way, but sorry, tangent, okay. Okay, you can't also meaningfully combine factors using C, like we often like to use C to combine all sorts of vectors and stuff. But here, you know, factor AB gets stored as 1, 2, factor BC gets stored as 1, 2, and so when you combine them, you get 1, 2, 1, 2. Probably not what you were expecting it to do, okay? And then the other thing about factors is, so for the gender factor, we had F, M, and X. And if you try to store a value that's not one of those things, it's going to say that's not allowed, invalid factor level, a missing values created here, okay? These are the allowed levels. All right, what R does frequently is coercion, okay? And this happens on the fly. R is a dynamically typed language, which makes it really convenient, but if you're also not careful, it can lead to confusing results, right? So if you have a language like C, it's what we call a strongly typed language, and if you do something like the integer 3 divided by the integer 2, it's going to give you back like the answer 1 rather than 1.5 and things like that, okay? Because it keeps the answers as integers, and you can't take like the average. You can't say what's the mean of this Boolean vector of trues and falses or logical vector of trues and falses, because it says that doesn't make sense. okay? But R is nice, and it says, all right, you gave me true, false values, and you're asking for the mean. Well, in that case, trues become 1, falses become 0, and I'll give you the mean, okay? And so the way it works is that because atomic vectors have to contain only one data type, if you combine vectors of different data types, it's going to say we've got to make them all the same data type, right? And so it coerces them into the same data type. And the way it works is it looks at, so I've got 4 vectors, the L for the logical vector, I for the integer vector, D for the type double vector, and CH for the type character vector. The reason why, what it does is it looks at the different types that are being combined, says what is the least restrictive type, okay? So I've got logical, integer, and double. In this case, double is the least restrictive type, and it's going to coerce everything up to that least restrictive type, in this case, type double. Here we've got character, and it says what is the least restrictive type, and that in this case it's character, and it's going to coerce everything into character, okay? So notice what happens to the L, the true false values, when I coerce them into doubles and when I coerce them into characters, okay? So if I combine the logical, integer, and double, the logicals get coerced into type doubles, and so I get a 1 and a 0. And if I ask, what's the type of this vector? I get type double. Here, the logical, the integer, and the character get coerced into type character, which means the 1 turns into the character 1, and the true false values get turned into the character values true false, okay? And this will be a type character. Right, is that all right? Okay. This coercion happens a lot of times as soon as you use some kind of function. So there's functions that do mathematical operations. That's going to turn everything to try to some kind of numeric value type, right? So we've already talked about this already, but if you've got a logical vector, false, false, true, okay, and you do any kind of operation that generally that is expecting numbers like sum or mean, it's going to coerce them into numbers. So false, false, true gets coerced into 0, 0, 1. And what is the sum of 0, 0, 1? We get 1. That's the number of ones that we have. What is the mean of this? We get 0.333, and that's going to basically be the proportion that's true. And that's actually very a handy thing, because you can run through a data frame and say, you know, what proportion of the people in my data frame are female. And you can say mean of this column, sex equals female. And it'll give you the proportion right away, right? So that's a very convenient thing. You can explicitly coerce things, okay? So you can say as.character, you can take false, false, true, and it'll turn them into a character vector, false, false, true. Or you can say make the numbers 0 and 1 into logical values, and we get false and true. But then sometimes you get, it's going to say, I can't do this, right? Like take the cat, right? Animal cat, the word cat, make it a number. It says, I don't know what you're talking about, okay? So there we go. Okay, here's some rules about explicit coercion. Okay, anything numeric that's not a 0 becomes true for as logical, right? So 0 becomes false, but everything else, 1, -1, 0.12, negative infinity, like a really tiny number, 10 to the negative 308, okay? Those all become true, okay? For as logical, these are the accepted spellings for falses and true. You can have capital F, all caps false, first letter false, all lowercase false, okay? Or these are the accepted spellings for true. Anything else will become NA. So if you give it lowercase f, lowercase t, these become NA. Why did the 0 and 1 become NA when I did this? Yeah?
Because the vector of characters is given?
Yeah, because what happened is I combined them with these character things, and so they became the character 0 and the character 1, and character values that aren't any of these accepted spellings will become NAs, okay? So normally if you do an as logical and a 0, 1, it will become false and true and things like that. But here, because I've combined them with character vectors, it coerces the 0 and 1 into character 0, character 1, and they get turned into NAs. Okay. All right, NA, what's the difference between NA, null, and NaN? This is also a homework question, and your answers are right here. Okay, NA is for missing values or unknown values, okay, which is different from non-existent values. Null is for non-existent values, okay? And then NaN is for not a number, okay? And it's basically undefined numbers, okay? Which is different from missing, NA, okay? NA, if you throw an NA into a vector, it does not modify, it does not coerce the vector into anything else because there is an NA for each type. There is a, what is this type? What is the type of this NA? If I do type of on NA, it's going to tell me it is a logical type, right? Because that is the most restrictive type. And so I can throw in an NA into a logical vector, and the vector will remain type logical, okay? But then if I throw in an NA into an integer vector, under the hood, R turns it into NA integer, okay? And this is the integer type for NA, right? Because an atomic vector has to be all of the same type, and so you can't have a logical NA value in a vector of integers. And so that becomes the integer type NA, okay? On the screen it all appears as NAs, but this is just to say that throwing in NA will not change the type of the vector that you're dealing with because there's a different NA type for every single type, data type that exists. Okay? If you want to check for NA, you cannot use double equals, okay? Because if you say NA equal to NA, it's going to return back NA, okay? Because basically, if I do 3 equals NAs, what is that going to return? If I say 3 equals NA, what will this return? False or NA? It returns NA, okay? Because you have to think of NA as, I've got a number in this box, but you don't know what it is, okay? Right? And I say, hi, here is the number 3. Is 3 equal to the number in this box? And what's your answer? Yes, no, I don't know, right? Your answer is I don't know, okay? And so NA is basically, I don't know, all right? And so now I've got 2 boxes, okay? I've got a number in this box. I've got a number in this box. And if I say, is this number equal to this number? The answer is I don't know. So NA equal NA is going to be NA, all right? And so, so that's what we've got going on here, okay? So if you want to say, is it in a box that I don't know? You have to use is NA, right? Is it a missing value? Then that says true, right? Do you know the number in here? Is it something unknown? Yeah, that's true, okay? Is NA. Null is the null type, okay? It gets its own type. If you say type of null, it's the null object. And then to check if it's null, you say is null, null, and that's true, okay? Is the null missing? That gives me back a logical 0. What is a logical 0? Logical vector, but of length 0, okay? So it's basically saying we're asking a question about something that doesn't exist, right? So I'm going to ask you a true-false question, and you go, okay, I'm ready to give you an answer. All right, what do you want to ask about? Oh, I gave you nothing, okay? So now you have no answer, right? This doesn't exist. It's a length 0 logical vector, right? You're ready to give a true-false answer, but it's for the null object, which basically isn't there, right? Is it logical? No, that's not true, okay? It's just, it's the null type, right? It's a type null, so that's what we have. Any type of operation that includes the null, right? Like a 0 length object, you're gonna get a 0 length kind of operation there, okay? And then if you try to like include null inside a vector, it's as if you're including nothing, okay? So combine 4, 5, null, and 3 is basically just combining 4, 5, and 3. All right, we'll get through this. Okay, we got vector arithmetic. I think you guys are familiar with this. So arithmetic in R is vectorized. So we've got 1, 2, 3, 100, 200, 300. If you add them, it goes element-wise. The 1 gets added to the 100, 2 gets added to the 200, 3 gets added to the 300, and you get 101, 202, 303. If you do the multiplication, 1 times 100 is 100, 2 times 200 is 400, 3 times 300 is 900. Okay, simple enough, right? And then we've got vector recycling, right? So here I've got this vector is length 3, this vector is length 6, and so what it's going to do is it's going to go element-wise, and then it runs out here, and then it recycles the vector, right? So it's going to add 1 plus 2 plus 3, 400, and it recycles back to the beginning, 400 plus 1, 500 plus 2, 600 plus 3, okay? Here, if you do something where this one's length 5 and this one's length 3, R is going to say, I'm not sure if this is what you wanted to do. Okay, it gives you a warning. It says, I did it. I said 1, 2, 3, plus 1, plus 2. We're going to get 502. But it says, but you know what? Most of the time, people wouldn't do this, but I did it for you. Okay, so it spits back, and this works. It doesn't complain at all. But over here, it says, just so you know, the longer object length is not a multiple of the shorter object length. But here's the answer anyway. Okay. And this is like a favorite question that employers put on their little interview. It's like a quick question that's easy, but also it differentiates people who are familiar with R and not, right? This question here. All right, so that's kind of your review on data types and things there. Go through. I would encourage you to play around with any of the code here. I'll put up the notes shortly, and learn about all this stuff. Okay, we'll see you guys on Friday. Go ahead and start taking a look at your homework assignment.